We've all been there, right? Your food delivery is late, and you're staring at your phone wondering, what is going on? Well, believe it or not, that simple question is actually your first step into the world of statistics. So today, we're going to follow that thread and see exactly how asking why can lead to a really powerful data-driven decision. Let's get into it.
You know, it always starts with something simple, a question that is honestly super common. It's the kind of thing you hear in meetings every single day. Doesn't matter if you're in tech or retail or, logistics.
And here's the big one. Why were deliveries so slow last night? I mean, it seems straightforward enough, but hidden inside that question is this whole puzzle that really only data can solve. This is the starting line for our entire investigation.
And that's the thing. You might think you just asked a business question, but what you really did was ask a statistical one. And that simple little shift in perspective, that's what takes us from just guessing to actually knowing. It's the key to finding a real, solid solution instead of just, going with your gut.
Okay, so to tackle a question like that, you can't just wing it. You need the right tools. And for this, we're going to use a framework called K13 to build out our statistical toolkit. It's how we're going to crack this case.
Now, K13 is all about being practical. This isn't about getting lost in super complex math. It's a pretty straightforward three-step process. First, you got to pick the right statistical tool for the job. Second, you use that tool correctly on your data. And third, and honestly, this is the most important part, you have to explain what your findings actually mean for the business.
All right, to start us off, we need to pull out our detective's magnifying glass. That's our first tool, descriptive statistics. This is basically how we get a handle on what happened. It helps us find the center, the sort of typical value in our data. But as we're about to see, how we find that center is incredibly important.
And this brings us to a really crucial choice, mean versus median. Now, the mean is just your simple average, right? But what if one delivery took a crazy long time, like 120 minutes? That one single delivery is going to throw the whole average off. The median, on the other hand, just looks for the middle value in the line. It ignores that one extreme case. And that's exactly why choosing the median can give you a way more realistic picture of what's actually going on.
Okay, so once we figure out what happened, the next logical question is, well, why? To find out, we grab our second tool, which is correlation analysis. This is what helps us spot if there are relationships between two different things in our data, to see if they're connected somehow.
And I think this is just a brilliant way to think about it. It's like seeing if two things dance together, right? Does one thing move when the other one moves? So if the number of drivers online goes down, do delivery times go up? If they move in a predictable pattern like that, they're dancing together, they're correlated.
But what if we could go beyond just seeing a relationship and actually predict an outcome? Well, that's where our third tool, linear regression, comes in. Think of it like a data-powered crystal ball. It helps us answer that critical question. If we change this, what's going to happen to that?
All right, enough theory. We've got our tools. Now let's put them to work. We're going to apply this entire toolkit to our fictional food delivery app, we'll call it Hungry Now, and solve their late-night delivery problem for good.
So here it is, our evidence, thousands and thousands of delivery records. We've got data on everything, delivery times, how many drivers were online, customer satisfaction scores, you name it. Our mission is to dig through all of this and find the key to faster, late-night deliveries and, of course, happier customers.
So the first thing we do is use our first tool, descriptive statistics, to whip up this chart. And boom, right away the problem just jumps off the page. Just look at that spike. Average delivery times absolutely shoot up after 10 p.m. We've just used data to pinpoint exactly when the problem is happening.
Okay, so this leads us to our key investigative question. We know deliveries get slower late at night, but we still don't know why. Could it have something to do with the number of drivers who are actually online? Well, let's grab our next tool and find out.
And this single number, this is the aha moment of the entire investigation. After running our correlation analysis between the number of drivers online and how long deliveries were taking, this is what we got. Negative 0.78.
So what in the world does negative 0.78 actually mean? It means we found a strong negative correlation. In plain English, these two things are definitely dancing together, but they're moving in opposite directions. As the number of drivers on the road goes up, the delivery time goes down. We found it. That's the root cause.
Now, finding the root cause is awesome, but it's not enough, not even close.
Now we have to use this insight to make a smart business decision. This is the part where we turn all that data into real-world action.
And here's how we get there. It's a clear path. Step 1, we used correlation to find the relationship. Step 2, now we'll use regression to actually predict the impact of changing the number of drivers. And finally, step 3, that prediction is going to directly inform a brand new company policy.
And our regression model. Wow. It gave us this incredibly powerful and specific insight. We're not dealing with vague ideas anymore. This is a hard number, a quantifiable prediction. It told us that for every 5 additional drivers we get logged in during those peak late-night times, the average delivery time drops by 2.4 minutes. How cool is that?
And that, my friends, is the ultimate payoff. This one piece of analysis led directly to a smarter, completely data-driven driver scheduling policy at Hungry Now. No more guessing games, just a clear, effective solution that's backed up by actual evidence.
All right, so we've solved the problem for our fictional app, Hungry Now. That's great. But how does this help you? Let's talk about how you can take these skills and frame them for your own career.
Okay, these I statements right here, they're pure gold for your portfolio, for your resume, for your next interview. They let you clearly and professionally describe the value you bring to the table. So instead of just saying, yeah, I know statistics, you can say, I use correlation analysis to find a strong link between active driver count and delivery delays. See the difference? You're showing exactly how you solve real problems. You know, we started this whole journey with a really simple, everyday question, and we ended with a powerful, data-driven solution. So really, the only question left is, now that you have the toolkit, what business question are you going to answer next?